Integrals and derivatives are concepts from calculus. While that makes them seem pretty complicated, they are very intuitive and easy to understand. An integral is the area under a function. Functions can be constants, lines, parabolas, or other curved shapes. The area under them is measured at each value of x, from the origin, across the x-axis, then up to the function. The area at each value of x is then plotted to form a new function. We start with the simplest example, a constant, y equals 1 for instance. At the x value of 1, the area is 1. At the x value of 2, the area is 2. This continues down the line, letting us plot the integral, y equals x. The integral of y equals x can be plotted too. The result of this is y equals half of x squared. If we keep integrating, we will notice a pattern. Each integration increases the exponent over x by 1. Also, each integration divides x by the exponent that the integration has put over x. To integrate more complex equations, equations with x's with multiple exponents, each exponent value is integrated on its own. For example, y equals x plus 1 becomes y equals half of x squared plus x, because x becomes half of x squared and 1 becomes x. A derivative is the slope of each part of a function. For constants and lines, the slope never changes, but for parabolas and other curved shapes, it does. For example, y equals half of x squared. At the x value of 1, the slope is 1. At the x value of 2, the slope is 2. The slope of each point can be plotted as y equals x. The slope of y equals x is always 1, so can be plotted as y equals 1. As you can see, derivation is the opposite of integration. Just like subtraction is to addition and division is to multiplication, derivation is the reverse operation of integration. As a result, derivation decreases the exponent over x by 1 and multiplies x by its current exponent. More complex equations can be split up and treated individually, just like with integration. One thing to note, integration and derivation do have slight differences. They don't perfectly cancel out. The derivative of y equals x plus 1 is y equals 1, because the slope is always 1. But the integral of y equals 1 is y equals x. Since derivative is just the slope of a function, the function can be shifted up or down and have the same derivative. Whenever an equation's derivative is taken, the constant term is lost, meaning that information is lost. When it is reintegrated, the constant has no data, so becomes 0. In conclusion, integrals and derivatives are simple and intuitive. They are very fundamental to calculus and have real-world applications as well.